Hey everyone, thanks for joining today's webinar session. My name is Marco Aguirre. I'm the research director at CoveTool, and I'll be hosting today's topic, which is going to be climate study, the climate report and site studies within CoveTool. Quick housekeeping before we get started. The session will be recorded and posted on our website. You can find it under the training sessions tab. And if you guys have any questions, aren't able to see today's session, always feel free to reach out to our support team live within the app. Also, if you'd like to get a copy of today's presentation, reach out to your sales executive or customer success representative, and we'd be happy to send you a copy. If that sounds good, if there are any questions throughout the session, always feel free to drop them into the chat box, and at the end, we'll open up the floor for any questions. Other than that, I'm going to go ahead and share my screen and get started. Cool. Yeah, if everyone can see my screen, let me know. Looks good so far, so I'll just get going. So a quick look at the agenda for today's session. We're going to be looking at climate and site studies within CoveTool. We'll have a quick introduction of what it is, how to read a climate study, understanding past strategies, understanding weather files, how they work within the energy simulations, how to create a report within CoveTool. Those are all the basics in order to just get started. And then we're actually going to go through the different climate diagrams with CoveTool and understanding how they can help inform your building design. We have a pretty extensive resource library where we do have a lot of different discussions, articles, blog posts on understanding climate strategies, passive strategies, things like that. So always go back to our website to reference more detailed information. But today we should have a pretty kind of in-depth, but also high-level introduction to how they work within CoveTool. So let's get started. Why is it important to have a climate and site analysis? There's three main reasons. First and foremost, they help us take advantage of all the different natural resources we have, things such as light, radiation, heat gain, natural ventilation, all the different things that can help us reduce our reliance on active systems. By looking at our climate report and better understanding how our client conditions can actually improve our occupants' comfort, we can help reduce energy consumption, thereby reducing carbon emissions. Also, with climate studies and the different types of graphics and reports you can generate, we can also start to identify potential issues before we even start designing the building. So just getting familiar with where you're designing, what's going to be happening, and anticipating what kind of potential solutions you can build into the project, the greater the impact you can have on the final performance and also on the building's final cost. One of the most important parts of understanding a climate report is identifying passive strategies. I think everyone's pretty familiar with what a passive strategy is, but if you're not, these are just building methods that rely on natural sources, energy sources like cooling, heating, shade from the sun and obstructions, ambient wind, things like that. And passive strategies help us reduce reliance on active systems, things that include mechanical systems, electrical energy, natural gas, utilities, things like that. There's a lot of different types of passive strategies, types of ways passive strategies can help inform design, things like massing, orientation studies, figuring out facade strategies, exploring things like shades, overhangs, fins, louvers. If you can explore massings that can help self-shade the buildings, or if you can take advantage of context in order to take advantage of any of these strategies, are great ways to do it. Incorporating natural ventilation, figuring out what the dominant axis of where wind is coming from. These are all things that can help reduce reliance on active systems. One of the key components to generate a climate report is going to be a weather file. If you're not familiar, weather files are just text documents that contain daily observations over a time period. The weather file that CoveTool uses is a TMY weather file. We have TMYs, TMY2s, TMY3s, and depending on which TMY version you have, that dictates a certain period of time where weather data was recorded, and then with all that recorded data, there was generated an average typical meteorological year. And that's the data we use to run energy analysis with, recreate the conditions of our environment that's going to help us predict how our building is going to perform, what kind of systems or strategies we need to incorporate in order to meet a certain level of comfort for our occupants. There's also a couple of other types of weather files. One of the other weather file types are predictive weather files, also known as future weather files. And this is the type of weather file that's going to help us predict what the anticipated weather stream will be in the future. So there's weather files looking at 10 years, 25 years, 50 years, 80 years, 100 years into the future. I've listed up a couple of resources of where you can locate weather files, future weather files. Right now, we do not have them incorporated into ColdTool by default. We just use the ones that are available on the Department of Energy's Energy Plus's website. You can see those resources in the help article. But if you'd like to look at future weather files, the data that they use to generate those files, here are some of the sources you can check out, like Meteornorm, WeatherShift, CC WeatherGen. All great sources. And if you have access to the load modeling tool, or if you have a trial with load modeling, you do have the ability to upload your own weather file, including a future weather file, to run analysis on your project. But it's going to be really important as we see shifts in the climate to understand what the anticipated weather conditions will be so we can better design towards them. Of course, this is going to become more and more important as we head towards some of the more detrimental climate conditions that we're on track to meet. So if you've seen the IPCC report, and this is also an ebook that ColdTool recently published, where we talk about the anticipated weather changes, the increase in 1.5 to 2 degrees Celsius changes and what that might look like for an environment. I've listed out some of those possible climate risks here on this slide. This is a really great graphic from the World Wildlife Forum. I always forget what the WWF stands for, but it just showcases the differences between one climate increase versus the more detrimental climate increase and what that can look like for our environment. And anything we can do to make our buildings more efficient can help reduce carbon emissions, will help reduce the impacts of climate change, and hopefully someday we can help reverse some of these issues. So it's going to be really important that we, start to better understand our climate, run the reports, get familiar with what we're trying to design for, and therefore deliver better performing buildings. So that was just a quick introduction to some of the climate concepts. Now I'll just talk a little bit about what ColdTool is going to do. One of the most important features within ColdTool, of course, is our energy modeling capabilities and the energy simulation that we run in ColdTool. Weather and weather files are a really important part of that. The way, if you're not familiar, the way we set up an energy analysis is we have to recreate the conditions of your environment. And then based on all the strategies, the material selections, all of the other performances that we use within your project, including the geometry to recreate what you've designed, that's going to help us determine how much energy we need in order to heat the space, cool the space, light the space. Depending on our system selections, we'll also see energy consumption coming from other areas like equipment, lighting, hot water, pumps, fans. All of this is based on what your climate condition is. So you can assume if you are in a location that has more extreme winters, you're going to see a higher increase in heating with more severe summers, an increase in cooling. And then if you can take advantage of your location's climate conditions and some of the past strategies that we're going to go through next, that can be a way for us to reduce our energy consumption. I think everyone's pretty familiar with why performance analysis is important, but it's always great to have a reminder. Buildings right now contribute 40% of total global carbon emissions. The typical lifespan of a building is going to be between 70 and 75 years. And we're going to see the building components, so different properties that we typically have to exchange between 15 and 35 years. So it's going to be really important that we can design buildings that are healthier, that last longer, that have smarter selection of systems, so we can reduce the impact that they're going to have on the environment. And of course, by running performance analysis and looking at all the things that we're going to be discussing today, it's going to help you verify the different decisions you make throughout the life of the project and hopefully deliver a better building. With that, let's talk about the ColdTool report. So if you've had the opportunity to create a report before, you probably would have seen it within the app. It's one of the icons that you'll see on the navigation bar. It's that cloud with sun icon. You can also see the climate report anywhere where you see a create report button. The create report button will be on the baseline energy page, the optimization page, and also on the home projects dashboard as that second icon. Wherever you generate a PDF report, it's going to automatically package the climate analysis with all of the other pieces of a report that we generate. The first part of the report that has climate information is going to be the section known as the 2030 palette. If you haven't used or know anything about the 2030 palette, it's a great resource for understanding case studies or other projects in similar climate zones or similar conditions as your own building, what kind of strategies they've been able to incorporate in order to make a more efficient design. I've described it as a kind of green building mood board and just trying to identify, this is an interesting strategy, is it something we can incorporate? And this climate report is going to select a series of strategies that work best for your location. If you're curious about any of those in the climate report, you can also click them and they're hyperlinked to a more in-depth case study where you can see a quick breakdown of how that strategy works, other projects that have used that exact strategy, and then a list of resources, tools, other things you can check out so you can figure out, is this a viable option for our building? And it's a really great just reminder of what the possibility and potentials are of incorporating more past strategies or just more intelligent strategies that are responsive to climate conditions in your building design. The second part of the climate diagram are the individual climate studies. So there's 6 climate studies within the ColdTool report. Each of the climate diagrams comes with help diagrams. So we're going to be looking at the 6 climate diagrams and how to read them, understand what kind of chart they are, what the different colorations and legends represent. So you can read them yourself and also just try to make an informed decision about what you should be doing in different climate conditions. The first climate diagram is the relative temperature and humidity charts. So these are 2 calendar charts. They're calendar charts because you see the different conditions mapped on a monthly and hourly legend. So the x-axis is months of the year. The y-axis is hours of the day. And here, depending on which weather file was selected, you can pinpoint the typical temperature of a specific hour in the year or the humidity ratio within a specific time in the year. Based on the legend, it's going to identify areas that are going to be too hot, too cool, if you're looking at the temperature chart, versus too humid or too dry with the relative humidity chart. In some locations, especially if you're familiar, if you live there or you typically design there and you visited a couple of times, it could be pretty obvious what certain climate conditions mean. You know, most folks are aware summer is hot, winters are cooler, but depending on your climate diagram, you can pinpoint exactly like what the seasonal trend looks like, where it peaks out during hours of the day, and that can help start designing for systems or other strategies. So here in that help diagram, you can identify things like taking advantage of water absorbing strategies in really humid locations. So there's a lot of natural stone materials, and also, what are they called? Finishes that absorb water, that can be great, or looking at dehumidification systems that are pretty energy intensive, but there's a lot of new strategies coming out about how to dehumidify a space. In the too dry area, incorporating more water features, like actually having ponds, courtyards, water circulation, things like that can help improve comfort. And of course, if you're within that middle range of the legend, you'll always have something called a comfort zone. So that's where most occupants will be typically comfortable within a range. It will vary depending on what climate type you're in. So if you're, the difference between like deserts, tundras, coastals, things like that. But this is a pretty comfortable range that you'll see in the climate diagrams. And then for the temperature help diagram, where it's too hot, taking advantage of things like fans, ventilation, natural ventilation. Where it's too cold, taking advantage of higher insulation, solar access, so the natural solar heating through the sun, so on. There's also a lot of ways you can map your climate reports to other factors of the building. So this is just, again, looking at the correlation between climate conditions and energy consumption. So this is a really interesting case study. It's a project in Korea. You can check out the white paper with that source down at the bottom. But it was just looking at the energy consumption for gas and electricity for the city in Korea, and then just looking at where that information was coming from and how it mapped onto the climate diagram. So here's two temperature charts looking at monthly gas and the peak seasons. Of course, it was all used for heating. For electricity, we saw a correlation between lighting, fans, cooling, heating. And then also I just wanted to mention dehumidification, if that's a strategy you've incorporated into your building design, can help determine like what our majority of our energy consumption is going to be used. Moving on to the next climate diagram, this is the adaptive comfort chart. So this is another calendar chart diagram, but this time it's looking in perspective. So in addition to the X and Y axis, you also have a Z axis. And with the Z axis, you can start identifying different peaks and seasonal peaks and valleys. So adaptive comfort just means how far are we from being comfortable? And it's a cross section between temperature and humidity. So the more uncomfortable the climate condition is outside, the further you are going to be from that comfort range. In this adaptive comfort chart, the yellow is considered the comfort range. Down here on the bottom left-hand corner, you can see a more traditional adaptive comfort chart, again, highlighting that comfort range and then some of the hours where you're outside of that range. Here, just anywhere where you have these peaks, it's going to be too hot, and then in the valleys, it's going to be too cold. Just another way to look at the earlier temperature and humidity charts. The next climate diagram is radiation by sky segment. So we do have two sky dome diagrams listed in the climate report. The first one is just total radiation. If you're not familiar with this chart, this is just looking at a sky dome in plan view. The further you're out from the center of the circle, that's going to be the closer you are to the horizon line in relation to your building. And then the higher you are to the center of the circle, that's the closer it is to right above the project. You can also see the cardinal directions, north, east, south, west, and then depending on the coloration of the different panels, that just represents the amount of radiation that area is going to receive over a typical year. This is a climate diagram I generated for Atlanta, Georgia. We don't have any direct radiation because we're in the northern hemisphere, and we don't have too much like cloudy days. If you have cloudy days, you can see some more bounce or indirect radiation coming from that direction, but we don't have too much of that. but we do have a majority of radiation coming from east, south, and west. And some of the more intense radiation, specifically in southeast and then just directly south of our building in the higher angles. So that's just from like 11 a.m. to 3 p.m., a lot of radiation that we got to worry about. With the help diagram that you have here, this diagram can be really, really helpful to identify what's going to be a really effective shading strategy, depending on where you're receiving a majority of your radiation. So the higher the intensity of the coloration, the more that can be used for passive heating in colder climates. The lower the radiation, the more ideal for glazing placement in hotter climates. Depending on what angle or like in which circle within the sky dome the radiation is being received, that can help indicate what shading strategies are going to work best. So if you have high, low angle radiation, which is typically further closer to the polar ends of the Earth, things like vegetation, frits, dynamic glass can be really great ways to control glazing, take advantage of beneficial radiation, and then also block glare issues. When you have a lot of the radiation coming from the middle ranges, so if you just look out 45 degrees from a window, you have a lot of intense sun coming in that direction on a daily basis. Things like light shelves, overhangs, fins, shadow boxes can be great daylight control strategies. And then when the radiation is coming directly above, and that's the most intense radiation, things like overhangs, cantilevers can be beneficial, and also smarter skylighting strategies. So instead of just using direct glazing above the building, taking advantage of things like clear stories or bouncing light into the space. You can see that also indicated here. So again, just looking at lower degree angles where that radiation is coming from, how to use ventilation, or not ventilation, vegetation and overhangs to shade the space. Interesting 45-degree angle strategies. Other effective 30 to 60 degree angle shading strategies. And then if you have a lot of direct sun at a higher angle, then just figuring out how to bounce light in other ways into your building. So you have a lot of natural daylight coming in, but it's not going to be a heating, cooling issue. The second climate diagram that you'll see, or the second sky dome climate diagram you'll see in the report, is radiation benefit. So radiation just means the energy that you're receiving from the sun. Some of that radiation can be beneficial, some of it can be harmful. You can imagine a really hot day where you're just standing out in the sun, can be incredibly hot, incredibly uncomfortable. But earlier in the day, some of that sunlight can be pretty comfortable, and it's just it's bright, semi-warm. That's what the difference is between beneficial and non-beneficial radiation. In this climate diagram, the non-beneficial radiation is going to be the darker bluer colors. So the less or the darker the blue, the more you want to try to avoid placing glazing here because it can become an issue, and also it can help identify some of the strategies that you want to take, like incorporating higher insulation or even tomb walls, things like that, to absorb some of that energy for other reasons. And then wherever you have beneficial radiation, that's optimal for placing glazing. You can see how some of those strategies are incorporated elsewhere. So I'm taking some of the 2030 palettes and just understanding where they make sense, where radiation is coming from, what kind of strategies you might want to incorporate, things like types of spaces, sun space, larger openings, slits, east and west shading strategies, and then also thinking about insulation, energy storage, all that. The second to last climate diagram is going to be the psychrometric chart. So this is the most intricate of the climate diagrams and can be the hardest to interpret. but I'll try to explain it. So what this climate diagram does is that it maps the intersection of 3 different climate conditions on this graph in the background. The different axes are temperature, humidity, and then with the intersection of temperature and humidity, you get the saturation line. And then the third axis is going to be the enthalpy line, which is the amount of energy that we have in the atmosphere. Based on the intersections of those different axes, we have different climate conditions that can happen at any direction. And depending on your location, you're going to see these little polygons of color, the red, yellow, blues, that will represent the hours of the year where those certain climate conditions are occurring. On top of the psychrometric chart, you also have these outlined polygons, the orange, the red, the blue, and the different shades of blue and yellows. And those represent where certain climate groups of climate conditions are occurring. So you can see things like over here, cooler, moderate, warm, dry, hot, dry, humid, dry, so on. And then finally, one more layer to the psychrometric chart is the comfort zone. So the comfort zone is that last polygon that shows you if your climate conditions intersect in this range, that's what is going to be the most ideal for your occupants. So no additional systems or strategies needed in that area. This climate strategy that Covetal generates is trying to figure out if we were to look at these other groups of climate conditions and figure out what we need to incorporate to move them towards the climate zone. That's what you're trying to extrapolate from that diagram. You'll see it in this percentage breakdown that's included in that report. You'll see the percentage of the year where those certain polygon group of climate conditions are occurring. So in this example, in Atlanta, 5.19% of the year, it's completely comfortable. And then the other polygons where other conditions are occurring. You want to try to identify the highest percentage and see how you can incorporate that as one of the passive strategies. So this really helps you shortlist which ones to go for. In Atlanta, internal heat gain, which is, or not internal heat gain, it's a typo, it should be solar heat gain now. But taking advantage of things like glazing for solar heat gain in the winter time, can be incredibly positive impact in Atlanta. Some of these other strategies are a little bit more complex to explain, but we do have a full article kind of going through each of these options, how they're meant to be used and how they can help improve comfort in your project. And the last climate diagram that we'll talk about today is the monthly wind rose analysis. So these are 12 different wind roses representing the different months in the year. Each of these wind roses maps the intensity, number of hours of days, and incoming direction of ambient wind. Based on the different wind roses, you can start identifying common axes of wind, so where the dominant wind is coming from, and then what times of the year you can take advantage of things like natural ventilation within your space. So you'll see that kind of further explain that help diagram. Natural ventilation can be incredibly powerful. Not every project can have it. It's typically where you have more mild climates or like tropical coastal areas, but it can be a huge energy saver as it reduces reliance on HVAC systems for cooling, heating, things like that. So identifying what the primary access for ambient wind is, and then figuring out how that design can help support ventilation through the space. And of course, there's a lot of positive health benefits to natural ventilation in addition to reducing energy consumption. Awesome. So that's everything that I wanted to talk about for Covetal's climate report and the different climate diagrams. Of course, there's a lot of other types of climate reports and diagrams that you can generate. We've collected a list of top resources that you can check out. You'll also see this in the climate diagram or the climate report section of our help center, where you can generate other things. Yeah, lots of information out there. Cool. That's everything that I had to share for today. Hopefully you found it really useful. Like I mentioned at the beginning, this session will be posted on our website under training sessions where you can rewatch it, share it with anybody on your team. If you'd like a copy of the presentation, just reach out to a sales executive or your customer success representative. They can send it out to you. And yeah, if you have any questions, feel free to just drop those questions into the chat box. I'll stay on for another minute to see if we have any questions coming in. While we wait, again, just want to show you inside the app, once you've set up your project, you can go ahead, jump right into the climate analysis page. If you're trying to generate a climate report without uploading geometry, you can do so by just using manual mode, which allows you to just manually enter in geometry information. And then if you just make a 10-foot cubed building, I'm just typing 10 in everywhere, that should be enough to give you access to the analysis. It's not going to provide any accurate energy analysis or any of the other parts, but it will give you a detailed climate report. So that's just one quick, easy way to do it. I don't see any questions coming in, so I think we're probably good to go. Thank you everyone for joining today's session. If you have any other questions, always feel free to reach out to our support team. Otherwise, have a great rest of your day.